Alright, welcome back to day 13. And it's about to open in a minute. So... yesterday we had a BFS pathfinding algorithm, which was fun, and it's always good to practice doing that because, man, how many times have I written BFS Dijkstra in my life, and yet I usually make a bug or something every time I do it, so just gotta keep practicing it. Alright, here we go. Distress signal. You climb the hill and again try contacting the elves. However, you instead receive a signal you weren't expecting. A distress signal. Your handheld device must still not be working properly. The packets from the distress signal got decoded out of order. You'll need to reorder the list of received packets to decode the message. Your list consists of pairs of packets. Pairs are separated by a blank line. You need to identify how many pairs of packets are in the right order. Huh? Okay. Alright, so each list starts with open bracket, ends with open bracket, and contains 0 or more comma-separated values, either integers or other lists. Each packet is always a list and appears on its own line. Huh? Okay. When comparing two values, the first value is called left and the second value is called right. Oh, this is kind of some sort of lexical graphical ordering or something, I don't know. Alright. If both values are integers, the lower integer should come first. Yeah, that makes sense. If both values are lists, compare the first value of each list. Ah, so we need some sort of recursive. So if they're lists, then you go to the contents. That makes sense. Alright, fine. If exactly one value is an integer, convert the integer to a list which contains that integer as its only value. Convert the integer to a list. Okay, fine. So basically everything's wrapped up in a list. If it's just an integer, then you pretend it's a list. Okay. Oh man. What are the indices of the pairs that are already in the right order? Determine which within the sum of the indices, and it's starting from 1. Okay. Wait, so what's the point? Why do we... Oh, okay, fine. And what was this line here? Each packet is always a list and appears on this. Oh yeah, okay, yeah. Each packet is a list. Got it. So basically we just have to interpret this as well as we can in code. So if we do it in the order they've done it, that's should be reliable. Alright. So let's have a look at this input. Yeah, okay. Alright, so we need to keep track of indices as well. We're starting from 1, so pair equals 1. Okay. Line equals dot read line. Hello, Fallen Thespian. It's 5 AM. I'm about to sleep. I saw you live and want to say hi. Thanks for the hi. Are you literally about to go to sleep now? So yeah, I'm doing this daily challenge. It launches at this time every day, which I guess is not great for Europeans because that's like 4 or 5 AM every day. I guess Europeans are not really competing, or if they are, they're staying up to compete. I'm not really competing, but I figure I might as well just do it at the moment the problem releases. So I get a line. We want to say while line. Because the line might be empty. Oh, actually we want to say line 1. Winners don't sleep. Yeah, I mean, that's pretty much the case for these programming competitions. A lot of the top competitors are from pretty varied places. A lot of them are from Poland, a lot of them from China, many from Russia. Why on line 1? Oh man, this is gonna... okay, so we can use Python's eval. So while a lot of people who are not using Python have to write some horrible parsing script, you can just cheat and use Python's eval. So say, what am I going to call these? Packet 1 equals eval of line 1, and that should just unpack everything automatically. Packet 2 equals eval of f.read. Get the next line. Strip it. I don't think we need to strip it, but... And then there's an empty line So I guess we just do f.readLine to exhaust the empty line. And then... Alright, just call this line instead of line 1. We only ever need one. Okay. Then we do custom logic. And then finally we do line equals f.readLine.strip. What happens if we call strip on a none? Alright, let's not do that. Alright, let's just test this works. Yes, it does. Okay. Now we need logic. So ultimately we are adding up all the indices we find. Oh! We also need pair plus equal 1. Result equals 0. So now for the logic. Alright, so we need to basically write our ordering. Basically, we're writing a less than or equal to method. I can do that outside here. So we say define less than or equal to left, right. This is going to return true or false. Return true for now. So if if packet 1 is less than or equal to packet 2, that means they're in the correct order. So result plus equal 1. And finally print the result. Alright, so that's the framework. 150. That's how many lines are, how many pairs there are, right? So there's about 300 lines. Python is neat, yeah. It's like the most readable language to people who don't understand coding. It just looks like natural language. Yeah, alright. Have a good sleep. Hope you don't have work tomorrow. Let's say, okay, so now the rest of this is just to fill in this method here. All right, now we get to the complicated bit. So let's I'm comparing two values. All right, so if left is an integer, how do we check if something is an integer? If type left is equals is, I don't know, type is integer? I am just guessing here. Int. Yeah, int, of course, not integer. Does that make sense? Let's just print left, see if this actually works. 0. Equals? Should I be doing equals? If wait, is this ever? Oh no, it's always. This is never gonna happen because currently they're lists. Okay, well we'll keep this. So if the left is an int, we say return. Oh no, we're saying if left is int and right is int. Return left is less than or equal to right. We just do that. No. Yeah, okay. All right, if both are lists, so let's print left here. Yeah, okay, that's... Should you be using is, though? Just... Yeah, okay, I think you normally should be using is. Not that... It would be the same, but there's a reason for it, I can't remember. Alright, so if they're both lists... oh man. Okay, so we need to account for running out of items. So, okay. For I in range length of left. So we wrote range over the left items. Or just the minimum. Okay, if compare the first value of each list, then the second value, and so on. So if we ever find right, if not let left I, right I. So if we ever get one where they're not less than or equal to, then we immediately return false. We've found a point where the order's not kept. So if we get this far, but we've never broken out of the for loop, then we just compare the sizes. Return length left is less or equal to length right. If the lists are the same length and no comparison makes a decision, okay, yeah. So then the last thing we need to do, so at this point, one is an int and one is a list. If type left is int, hang on, let's say new left equals left if, so we put wrap left up in a list if type int is type left is int, else else we keep it as the list. Hello, DIJ. And now right equals right, wrap up right in a list. And then what? We return new left is less than or equal to new right. That should be the whole method. So how goes the challenge? It seems alright. So it's something about I'll switch to the browser in a minute. Let's just run this and see if I get something. Oh, oh, whoops. I should be using my custom less than or equal to. Six. Ah, but I shouldn't be adding 1. I should be adding I. Not I. I should be adding packet. Not packet. I should be adding pair. 394. Alright, let's try that. Damn it! Yeah, I mean, this is a slightly tricky wording. Alright, well then I'm gonna have to have a look at the problem again. Alright. So, this is the problem. So, basically you get given a pair of lists. But the awkward thing is the lists can contain other lists arbitrarily. And those lists could contain other lists and so on. You could have nested lists, like this one here. The idea is you're trying to check if the first list is less than or equal to the second list. And when I say less than, they've defined a custom meaning of order here. So the rules are, if the first thing is an integer and the second thing is an integer, then you just compare them as if they're integers. If 5 is less than or equal to 6, and so on. If they're both lists, then you go by the individual items in the list. So you compare the first item with the first item of one with the first item of the other, second item with the second item with the other, and so on. And if you do that and you run out of items to compare, like here, for example, then you go by whichever's the bigger list. So you want the first list to be of smaller size, smaller or equal size to the right list. Otherwise, it's not less than or equal to. It's kind of like lexicographical ordering in a dictionary, but kind of a bit more complicated. So, and then the final condition, if one is an integer and the other is a list, then you have to wrap up that integer in a list. So for example, here, comparing item by item, so I'm comparing 9 with this list here. So I have to wrap up 9 as a list first, compare that with 876. And because for the rules of lists, we go item by item, so we compare the number 9 with the number 8. Because 9 is not less than or equal to 8, that's false. That means the original packet is not less than or equal to the original second packet. I don't know how easy that was to understand. It's pretty confusing overall. So basically, I've tried to interpret this as in code. Right, let's try the example because I failed on the actual test data. So the summary is really you're trying to find whether the first is these pairs, these two items are in dictionary order. You say true if they are, but not dictionary order, a custom dictionary order. It would be sort of funny if the example data gave you the right answer. Well, that's happened to me, and that made it problematic to debug the problem. So I'm hoping it gives me the wrong answer. I got 11 here. Correct. Okay, so the correct answer for this example is 13. Good. So we can debug this here and now. Alright, so I'll just print the actual pairs. So I've said 1, 4, 6, and 11. No, 1, 4, and 6 are in correct order. They've said 1, 2, 4, and 6. So I've failed on 2. So let's have a look at 2. 2 is this one. So I said this is not less than or equal to this. I said this is not in order. They're saying it should be. So let's do this manually. So we compare that item with that item. We should say they're less than or equal to because they're the same thing. We move to the next item. We compare this item with this item. This is an integer, so we have to wrap this up as a list. So we end up comparing 2, 3, 4 with the list 4. We go into the first item, which is 2, compared with 4. Say that's less than or equal to. Move to the next item, but then we run out of items. Hang on. I thought if you run out of items, then that means the first packet was bigger than the second packet. Maybe I've misunderstood the rule then. Alright, let's go to the browser. Alright, so we compare that with that. compare 1 versus 1. So you go into the items, you compare 1 versus 1. Alright. So now you move on to the next items. You compare 2, 3, 4 versus 4. You have to wrap 4 up. So you rewrite it as 4, like that. Now you compare 2, 3, 4 versus 4. I think I'm doing that so far. Compare 2 with 4. And you finish there. Okay, that's what I'm not understanding. So there's this section here. Compare the first value of each list, and so on. If the left list runs out of items first, they are in the right order. If the right list runs out of items first, they are not in the right order. Huh? But the right list did run out of items. Didn't they? Right. So this is left list, this is right list. They've said it only compares the first number. Well, yeah, there's only one number to compare. And okay, so 2 is less than 4, so we continue to the next item. But obviously we've run out of items. So if you go by this ruling, it should say the left list runs out of items, they're in the right order, and if the right list... So we're in this condition here, the right list has run out of items. So the way I'm reading this, it seems like it should not be in the right order. I don't get it. I mean, the example just says left is smaller. Yeah, but this check is for this comparison here, 2 versus 4. It's ignoring the list stuff. So it's... Oh, I see. Okay, I see what you mean. It's saying, no. Well, the moment they have the bold thing, that means they've decided the ultimate result. So they've said left side is smaller, so 2 is less than 4. But they shouldn't reach a conclusion there. They're supposed to continue and move on to the next item. So I still don't see how... What... Oh, yeah, now I get it. Okay, yeah, I have misread. I have misread this. Yeah, okay, so I wasn't actually doing lexicographical ordering. I was doing something weird, like co-lexicographical ordering or something. I forget my combinatorics. Yeah, that was me being stupid. This is what I've done is not even like dictionary order, because I was comparing the first 2 letters say, let's say, aardvark and balloon, or apple and balloon, A is less than B, and then I was moving to the next letter, but I should have stopped there, because the moment you've seen that A is less than B, you're like, okay, apple is less than balloon, we should stop there. But I was actually moving on to the next letter. Whoops. That was dumb. So, yeah, I've done this completely wrong. So, what exactly did I do? I said, okay, so that line there is wrong. Turn left leg. What we actually want to say is... No, that's correct. The integers comparison is correct. The list comparison, the moment we see... Oh, wait, hang on. This is not a true or false thing. It's a tri-state thing. It's either less than, greater than, or equal. So I've been assuming it's either less than or not. I need 3 states. If it's equal, we need to return that as well. So we shouldn't be returning booleans. Instead, what I should be saying is, let's call this compare. And we're going to return a -1 if left is smaller. Let's actually write this out. -1 if left is smaller. +1 if 0 if equal, +1 if left is bigger. I mean, we don't have a notion of bigger, but whatever. Okay, so let's do this again. So if left smaller than right, return -1. If left greater than right, return 1. Else return 0. Let's just write this out explicitly. I think this is the way to do this. You need 3 states, not 2. So now we go to the list. We say, all right, so for each item, comparison equals compare left item with the right item. Yeah, this is proper lexicographical ordering, how it works. So if comparison equals -1, we immediately say we now know that's less. If comparison equals +1, return 1. Otherwise, it's a tie. And we'll just move on to the next one. So if we get as far as here, we base it on which list is smaller. So again, we have the 3 states. So we can actually be smart about this and say turn compare the actual integer length left, because this works. And then finally we wrap up left, we wrap up right, and then we piggyback on, we call compare recursively here. Alright, let's run that. Compare. So now we're saying if compare equals -1, is what we're looking for. 1, 2, 4, 6, and then we end up with 13. So we got it right on the example. (6101). All right. That's certainly a bigger number. Yes, it's correct. What would happen if we just compare the strings? Would it just work? Using normal lexic? No, I don't think it would. No. Because it's not checking for sizes of lists. No. Alright, so part 2. Now you just need to put all of the packets in the right order. Ooh. Sorting. This is the textbook algorithm every computer scientist learns on their first day. Well, maybe not their first day. But how to sort data. Which is an incredibly important topic to study, and there's just, the research goes on forever. All the different techniques. It's so important to sort data. And sort huge amounts of data. So now we basically need to implement sort, but using our custom comparison methods. So two additional divider packets, 2 and 6. What? Why? Okay, fine. Organize all packets, the ones in your list, as well as the 2 divider packets, into the correct order. Fine. Then you use the dividers to do something. All right, let's first try and do this first step. Okay. So we want to add these 2. I guess we can just copy and paste this into the input file. Whoops. Yeah, like this. I think we do actually want to leave a space at the end. Okay, so now our compare method is fine, so we need to just comment that out. So now we're on part 2. In case I ever want to go back to part 1. Alright, so for fact, we don't need the... Okay, we can just comment out this entire thing. Alright. Part 2. For line in f.read lines. So packets equals just a list. For each line, packets dot append line dot strip. So we put all... Oh, if line is not empty, well, line dot strip, because it might be a new line character. All right. Print packets. So that's what we've got. Oh wait, we need to eval. Print eval. Oh, how I love eval. Those poor non-Python programmers having to write their own parser. Maybe some other languages have something similar, but I don't think they do. A lot of them don't. That just immediately turns it into a real list of lists. Man, I can't imagine doing this in C++ because you need strong typing there, so you need to define. You can't just have an arbitrary list of lists in there. Well, yeah, C++ you have to be clear on what item is in your list, and you can't have different types of items, so you can't have one integer and then the next thing is a list. So you have to, I don't know what you do in C++. I'm not really a C++ programmer. You would have to have layers of integer pointers to tables, something. Or you could do it by the strings. One of the strings is I don't know. Don't care. So now we want to sort this. I forget how to, so I'm gonna have to look this up. Python sort. So you have if you want to use a custom compare method, you want to... I don't want to use key. Sort. Python sort uses key, but I don't actually want to use key. Or do I? No, key assigns a value to each individual item, but we want to compare two items. Sort with custom comparator. This is one rare example that I know how to do in C++, but I don't know how to do in... Python. Oh, you can do it with key. But yeah, key equals compare. Key equals compare, you just do, oops. Okay. So So we want packets.sort key equals compare. Let's have a look at this. I think this will just work. Compare missing one required positional argument. Right. Have they changed the way this works? Because, okay, the Stack Overflow thing I'm looking at suggests that you can have a compare, which takes 2 items, and you can use that as a key. Maybe they changed it? I'm getting mixed explanations here. So one thing is suggesting use this. I don't think that exists. Maybe it existed in the past. No, can't do that. Oh, they're using sorted, not sort. Sorted is slightly different. Weird. Okay, so packets equals sorted packets like that. No, they still don't have CMP, but so we want to turn that to a list. Does it have key? No. What? How'd you do this? Have they removed CMP? Because I'm seeing CMP in all these answers. Well, now this is interesting. All right, well, okay, there's a different thing that's being suggested here. Use comp to key. So I reckon they've taken comp out. Let's try and find an actual proper source for this. CompPython sorted. Ah, they did. They took comp out. Why? Okay, fine. So but you can bring that back, or you can bring back the behavior by, what am I looking for? All right. So what we need is from functools import comp to key. That's what we need, and it will convert our comparator to a key function. So key equals comp to key compare. We don't need this. We'll just do dot sort. Unmatched. Oops. Yep. Alright, that is useful knowledge. And now we've sorted everything. Okay. All right, the next step. So we need to locate the divider packets. So we need to find the 2 and the 6. Find the indices of the 2 divider packets and multiply them together. Okay, so we need to find that. Python knows how to do nested equality of nested lists. It just calls it recursively. So that should be easy enough to. So let's say I equals. Oops, let's go back to the packets.find. No, packets.index. That should just work. But we want to add one as well. Let's try that. Yeah. J equals 6. And then print I times J. Two 1909. All right. I mean, I feel like if we got the comparator working, then there's nothing much that can really go wrong here. Yeah, it's fine. That was a good problem. I think custom comparators and sorting gets neglected a lot in these kinds of competitions. Like, it's a very important topic, and it's a good thing. It's a good skill because it actually does come up in real jobs a lot. Custom sorting databases or entries according to some kind of criteria you actually want to sort on. Knowing about lexicographical, co-lexicographical ordering is also important. This problem is so much easier with Python. I wouldn't know where to begin with other languages. So yeah. Let's see what my rank was for that. I think if a lot of people are not using Python, I could actually have a decent rank. But then again, I wasn't exactly doing it very fast, was I? How do I find my... 2831. It's decent. Yeah, because it is very textbook, so I'm pretty sure a lot of people will just know exactly what to do out the box, especially when I had to Google how to use the sorting. So they've changed. I mean, it's been a long time since I did custom sorting in Python, but they've changed how it works. You have to use a key now, which is interesting. But I mean, you could just restore the old behavior by using comp to key. That's basically what. That's the conclusion there, apparently. I don't know what it's doing behind the scenes. How does it make a key out of a compare? You can't always do that. Because compare theory depends very much on some custom logic that's comparing 2 items. How do you transform that into a key function? I don't know. I should look into that. So that was today's problem, and I guess I can treat myself to some lunch now. the earlier I finish these. So these problems always launch at exactly 12 midday for me. So that's good motivation to solve these quickly. Alright. Yeah, I think I'll just go for some standard, cheap Thai food, maybe like a papaya salad or something. Alright, see you later, DIJ.